time I try to debug my mind, my code's a riddle, you always whine. You find the errors in every nested loop. Oh, clever llama, master of the code. You solve our mysteries just like I was told. VFDs and VLCs, you know them well.
Welcome back to another video. In today's video, we're going to talk about how to get the MCI210 module to talk to a bus coupler using Modbus TCP. If you're familiar with CoDeSys, this will be very familiar to you. That is because Machine Control Studio is a CoDeSys platform. Hopefully this video answers your questions. This video is going to show you how to set up the Modbus TCP using the MCI210 module. And because of that, I've skipped a bunch of steps to get me to this point. All I have here is a standard project setup with an M700 drive and an MCI210 module. As you can see, I have two applications here. I got one built into the drive and one built into the MCI module. I'm going to delete the one that's built in the drive just because it makes the project look cleaner. So as you can see here, I have two Ethernet networks, the one right here and one right here. They are fundamentally different ports on the drive. This one here is the built-in Ethernet ports on the M700, and this is the built-in Ethernet ports on the MCI210 module. We're going to be using this particular port for our setup. So if you try to do it with this one, it's not going to work. It doesn't support Modbus TCP master. Okay. So the first thing we need to do is come down here, right click on it, select Add Device. Here you will see that it supports the Modbus TCP master. Hit Add Device. As you can see, it's added this Modbus TCP master underneath the Ethernet port. We'll click on this Modbus master and the list of things will update over here. We are now going to select Modbus TCP slave and hit Add Device. Now it's important to note that you'll need to add a device for each bus coupler that you put in your system. I only have one bus coupler that I'm using today, and so I'm only going to have one slave device. Please note that there is a limitation on the number of slave devices the MCI210 module supports. I believe it's 4 devices currently. That might change in the future, but today it's 4 devices if I remember correctly. So over here on the left side, you can see it added my Modbus TCP slave device. I no longer need to add anything else, so I'm going to close this Add Device window. You'll also notice that there is some code up here called autocode that was generated the moment I added this slave device. The nice thing is that all the code will be automatically generated for us by us editing this device. So right now, if we come over here to this little program called Write Mappings, you can see there's no code in it. And you can also see that in the read mappings, there's also no code in it. But later on, as we edit this device here, we'll come back here and look inside there and there will be a bunch of code added. But before we modify anything in here, we need to fix this squiggly line. Now you may not have a squiggly line here, but I always do, and that's because my library manager is missing the library. The library it's trying to use is this CT Modbus client version 1.12.3.1. I don't have 1.12.3.1 installed on my computer, but I do have an older version that's installed. So I'm going to come up here to Add Library, Control Techniques, Features, and here's the Modbus client. As you can see, the name is the same, CT Modbus client, CT Modbus client. Now the moment I add this, you will notice that it's a different version, right? It's slightly older than the version that it's trying to use. That is okay. It's not going to cause any problems. This is the one my Machine Control Studio came with. I'm not sure where this came from, but regardless, this worked perfectly fine. If you look over here on the left side, the squiggly lines have disappeared and everything's happy. Now, the one thing I don't like about this name over here is that it's called Modbus TCP slave. That doesn't really mean anything from the point of our application. I would recommend that you name each of your bus couplers or slave devices based on what it is. So I'm going to rename mine Bus IO. As you can see, a window popped open, and it's just making sure that I agree with the changes it's going to make. I'm going to hit OK. Now the next step we need to do is make sure that the master's IP address is set up. So we click on the Ethernet port here, come up here to the top under General, and you'll see the IP address that it's going to use for the MCI210 module. This is the correct IP address for my MCI210 module for my application, but it'll probably be different for yours. We don't care about anything else in these tabs. Next, we'll skip all the way down to our slave device, and we will set up the IP address for our bus coupler. Now, this doesn't actually set up the IP address in your bus coupler. All we're doing is telling the MCI module what is the IP address of the bus coupler. To set up your bus coupler, you're probably going to have to use a software called ipconfig if it's a Phoenix device, or you'll have to use a web page or something else. The next thing we're going to do is click on this tab right here. And this tab is where we set up all of the inputs and output words for our Modbus protocol. To add something, we need to come down to Add Channel and give our channel a name. Now, when I'm using a bus coupler, you might note that bus couplers have these things called slices. So I like to name each channel the slice number that I'm actually going to be talking to. So I'm going to call this one Slice 1. Because I'm going to be talking to my very first slice. And my first slice is technically all digital inputs. So we're going to read these inputs. So what you need to do is open up the manual for your bus coupler and find out what address your input registers start with. Now for me, my inputs start with register 0000. Okay. And so if I had more than one slice of IO in mine, then each slice of inputs would increment this number by 1. But I only have one slice of inputs, so I'm just going to use 0000, and that is the default setting here. Now I'm going to add my slice of outputs. So my second slice is digital outputs. And I'm going to write to these digital outputs. So I'm going to use write single register, function code 6. And if I come to my user manual, that address 800 is the starting address for all of my digital outputs. You'll notice that there's a 0x at the beginning. 0x refers to hexadecimal. Now, some bus couplers do not label their Modbus addressing in hexadecimal format. Okay? And if that's the case, then you'll need to delete this OX at the beginning. Now you can see I have two slices in my Modbus slave device. One is reading address 0 and the other one is writing to address 800. The next tab here is the initialization for the Modbus device. Now what you do here is you click New, and you'll notice that there are only write functions here. This is because you're going to write something to your Modbus bus coupler the way you want it to start up. So I don't want any of my outputs being on when I first power up the system. So I'm going to set it to a value of 0. So every time the system powers up, all of the digital outputs will be forced automatically to a value of 0. In other words, they will be turned off. Here you can see that I have a single line item. If I had more things than one thing to do, that's okay. I would just keep hitting new for each and every item I wanted to modify. For example, in your bus coupler, you might also have something called a watchdog, right? And so here I do have a watchdog that I could set up, but I'm not going to actually set it up. So this is really nice, being able to initialize your bus coupler so that it's all set up the way it needs to be. Now, some bus couplers on power up, you are forced to do a reset command. So this would be a perfect place to send a reset to the bus coupler in order for it to start to work. The next thing here we're going to go to is this tab. Now this tab basically just gives you some good information, and you can expand things and look at the function codes for each of the slices and other good pieces of data. We're not going to do anything with this today. The next tab below that is where we start to actually make magic happen. In this window, you can see that I have both of my channels I created from the earlier tab. Here you'll see I have slice number 1, which is my input. You can see the description over here. I'm reading a holding register. If I come over here to the left side and expand it, you can see I have all these little arrow things pointing to these little square box things. Basically, this is what we're going to use to map it to our local variables. Unfortunately, I have not made any local variables at this time, so we need to do so. So over here on Applications, I'm going to right click and say Add Objects, and you'll see something called Global Variable List. Normally, I will change the name of this to something that means something to me so that my code is easier to understand. But today, since I'm not really doing anything, I'm going to just leave it as GVL and hit Open. Now, if I double click on GVL, you will see I have a window called GVL, or Global Variable List, opened up. I'm going to expand this a little bit, and I'm going to make a couple variables. Now I have a couple variables. I can now use them in my bus coupler. So if I come back over here and expand this and click on the second one down. Now don't click on here. We don't want to link it to this. This will not work for you. You want to make sure you click on the second one down, and we're going to click on this little button here. This little button pops open this thing, and we're going to navigate to my application, GVL, right? Because that's what we name our global variable list, and inputs. We have now successfully linked our global variable to this channel. Let's do the same thing with our outputs. Now that they're both linked, we can now download to our MCI210 module. So now you can see my bus coupler on the screen. So now if I come over to global variable list and I look at my inputs, I can see that it shows a value of 0. If I turn on one of my inputs, you can see that my input turned on. As you can see, the inputs are working perfectly fine. Now, how about the outputs? So let's send a value. As you can see, my digital output number 1 turned on. And now you can see digital output number 2 turned on. So that worked out pretty well, didn't it? But maybe you don't like to read and write values. Maybe you want something that means more than just inputs and outputs. Well, we can do that too. If we come back to our global variable list, let's delete inputs. And let's actually use some booleans and name each of our inputs, or at least a few of them. All right, now that we have some boolean inputs and outputs, let's go back to our bus coupler and come to our mapping here. And let's delete these old variables that we had it linked to. And what we're going to do is, instead of linking it here, we're going to link to each and every one of the bits, right? So my first bit, I'm going to call it run. Then I'm going to call the next one home system. And the next one, reset. And now I'm going to map some of them to my outputs. Now that we're done with that, we can download. Start the code. And if you look at this, you can already see that these inputs are on. Right? I can also monitor these, of course, in the GVL. Remember our global variable? Okay. And I can also write to these outputs. But I can also monitor them here, which is kind of cool. As you can see, there are some lights on my digital inputs that are not showing up here. And that is because they're not mapped to anything, and therefore nothing is tied to them, and therefore these do not update. So earlier in the video, I said that this bus coupler, as we edit the values, automatically generates code here. And I said I would show you what that looks like. So I'm going to do that now. So here in the initialization, here is all the code it wrote for you. It sets up the IP address and some other stuff. Over on read mapping, you can see it's written a little bit of code, but you can see really all it's doing is linking our global variables to our bus coupler. And that's the same thing with the writes. It's just in reverse. And right here is our main piece of code that's written. Now, each one of these pieces of code are actually called by the freewheeling task. So if I open up the freewheeling task, you'll see that it's calling a read from the device first, then it processes the device, and then your code, your freewheeling code runs, and then the writes happen. And so it kind of does it in this pattern here. So in short, you don't change any of the code here. You just use the little wizardy setup thing down here, and it just sets up everything. Thank you so much for watching. If you found this video helpful, don't forget to subscribe so you don't miss out on further content. And remember, if there is a specific topic you would like me to cover, just let me know. I'm always open for suggestions.